Hello, PreCalc. This is to be viewed on Wednesday sometime after class, and that's November 2nd. And we're in review mode, and hopefully the problems that I practice with you tonight will help you on your take-home test. So keep in mind that we have a deal. If you do 6 problems, well, you may have already lost the deal. If you brought in 6 problems today, on Wednesday, that were completed on your test, and you do another 6 tomorrow, then you have, well, you bring in tomorrow, then you have the option of dropping one whole problem from the test and getting it scot-free. You'll have it marked correct without even doing it. All right, let's look at we were talking about inverse trig last night. So I'll just remind you how that works. So if you're looking at the secant of the tangent, inverse tangent, that's what the -1 of 2 is. This is not going to be found on the unit circle, so we can't find a tangent of 2 on the unit circle. So we're going to have to draw a triangle. Tangent is in the first and the fourth quadrants only. Arctangent, I mean. So we're going to draw it in the first, and the opposite, tangent is opposite over adjacent. So we have an opposite of 2 and an adjacent, it's 2 over 1, 2 over 1. And the Pythagorean theorem will get you this unknown side, and it will come out to be square root of 5. So now we're going to take the secant of that angle right there that I just drew. So the secant is hypotenuse over adjacent. So hypotenuse over adjacent. So the answer to this problem is square root of 5. Hypotenuse over adjacent over 1, which is just square root of 5. So the square root of 5 is the answer. All right, we did some of those last time, so I just wanted to show you that some of those are found on the unit circle. So if I asked you for just the arc sine of 1, that is saying what angle has this as its sine. So we can only look for arc sine in the first and the fourth. So sounds like monkey math. 0, 1, 1, 0, 0, 1, and 0, -1. So we're only allowed to look within here. And it turns out that the coordinate, the point that has a coordinate, the second coordinate of 1 is right here. So that's pi over 2. So these are quick ones. Just look for them in the unit circle. Try another one. Tan inverse of square root of 3. We can find that on the unit circle. So let's take this one, 1/2 over the short guy, I'm sorry, it's the long guy. Square root of 3 over 2 over and 1/2 up. When I divide this by this, will I get square root of 3? I will not. So tangent is the second divided by the first coordinate. But maybe it'll work over here. Over the short, up the long. I believe it will. When I divide square root of 3 over 2 by 1/2, I do get square root of 3. So that happens right there, and that was at pi over 3. And arctan we can look in the first and the fourth, so we did not fail that requirement. Our cosine say of minus square root of 3 over 2. Cosine, arc cosine, you can look in the first and the second quadrants. And if we look there for a first coordinate of negative square root of 3 over 2, think it's right here because we go back negative square root of 3 over 2 and up 1/2. So we are at that spot. And this value is 1, 2, 3, 6, 4, 6, 5, 6 pi. So the answer is 5 pi over 6. All right, so inverse trig, the last one we'll do is the trickier one where you have an expression inside of the inner chamber here. And we'll make up one. Let's say 2 plus x over the square root of x. So you're definitely not going to find an angle that has this as its cosine on the unit circle. No, no, no. So we're going to have to draw it. So when I draw it, I'm going to get an adjacent over hypotenuse. And the biggest pain on this one is coming up with the third side, pythagging it with these variables or expressions. But we have to do it. So I'm going to say this squared plus this unknown, I'll call it b, plus b squared equals square root of x squared. All right, we have to multiply that out. We get 4 plus 4x plus x squared. So if you multiply 2 plus x times 2 plus x, there's 4 steps. And you will get this. Plus what we're looking for, b squared. And the square root squared is just an x. So you have to solve that for b. So I'll start with b squared. So I'll move everything over. The 4x will combine with the x to give you a minus 3x on this side, minus 4 minus x squared. And finally, b is the square root of that. So sloppy, woppy, yucky. All right, let's put sloppy, woppy, yucky over here. It's sloppy, but it's doable. So we're going to get this big expression from our work here. So negative, square root of negative 3x minus 4 minus x squared. Alright, so even though it's sloppy, can you take the sine of that? Once you've done all the hard work now. So the sine is opposite. That's that slop we found. Over hypotenuse. And on this one, you don't have to rationalize it. You just keep the radical in the bottom. And that would be your answer. So these don't work any differently than these did up here. It's just that you have more of the unknowns, you have longer expressions to work with. All right, I want to talk a little bit about bearing, and that's about it for tonight. So on bearing, we have a situation where we have something like this. In the north, 13 degrees east. So you always work with a north, south, west, east grid. So this tells you we start on the north pole and you go 13 toward the east. So mark that 13, and that is the expression that's marked by that bearing. So what you're going to have to do is you're going to have to look at a figure. Say there's a figure here. It's like a quadrilateral, and we'll say this is a right angle, but these aren't. So I'll make them look less like right angles. All right. So I have a quadrilateral, four-sided figure, and there's a right angle here. So I am going to give you the bearing from A to, we'll call this A, D, C, and B. I'm going to tell you the bearing from A to D is north 8 degrees west. So you have to create a grid, north, south, east, west grid. If you're going from A to D, you're going to start at A. You're going to go north to start, and then 8 degrees west. All right, this is not drawn to scale, so let me move this side so it's skinny. It's only 8 degrees, so that's not very big. So this quadrilateral right here, this is 8 degrees. And see if you can put in the bearing, say that the bearing from B to C is north 10 degrees west. Similar to what we just did, north 10 degrees west. So if we're going, the bearing from B to C is north 10 degrees west. You got to draw a grid at B. You're going to go north and then 10 degrees west. All right, can you find the bearing from A to B? So we already have a grid here. So what we're looking for is this amount right there. So how far is that? I have to pull out a little bit of geometry to figure that out. This is 90 degrees in here. This was 10, so to get all the way over to here, we know a straight line is 180. So we've got 100 between here and here, so this must be 80. And now, if this is 80 by alternate interior angles, this is also 80. So when a transversal cuts two perpendicular lines, that's the north poles, they create equal angles. So Miss Grace would be so proud. So 80 and 80. So now I have the bearing that I need. It's my timer. So I'm going to go north 80 degrees east. And that is the bearing from A to B. All right, north 80 degrees east. So I use a little bit of geometry and a little bit of what I know about bearing, and I was able to find the bearing from A to B. All right, hopefully that'll help you with the bearing problem that will come your way. And I'm running out of video time here, so I'm going to say goodbye.